Imagine waking up one day to the news. Scientists have discovered a way to travel faster than light. Sounds like something straight out of science fiction, right? But what if I told you that some theories suggest it might actually be possible? What if we could reach another star in days instead of centuries? Could we bend space, create wormholes, or ride a warp bubble like in the movies? Or is light speed truly the ultimate limit? Today we're diving into the mind-blowing possibilities of faster-than-light travel, and trust me, you don't want to miss this. Ready? Let's go! The speed of light. Hey, have you ever wondered why we're stuck crawling through the universe at such slow speeds? I mean, think about it. Our fastest spacecraft takes thousands of years just to reach the nearest star. But then we hear about the speed of light, the ultimate speed limit of the universe. So why can't we just press the gas and zoom past it? Well, it turns out Einstein had something to say about that. His theory of special relativity tells us that as you get closer to the speed of light, 299,792,458 meters per second to be exact, things start getting weird. Your mass increases, time slows down, and eventually, it would take infinite energy to push you past the light speed barrier. Yep, infinite. That's more energy than all the stars in the galaxy combined. Now, you might be thinking, okay, but what if we just built an engine that's ridiculously powerful? That's the problem. No matter how much fuel or thrust you have, you can't outrun light. It's like a game with rules we can't break. And if we somehow did, weird things could happen, like time travel, causality-breaking paradoxes, or even physics itself collapsing. But hold on. Before we lose hope, some wild theories suggest that maybe, just maybe, there is a way to cheat the system. Enter warp drives and wormholes, two mind-blowing ideas that could rewrite everything we know about space travel. So, is faster-than-light travel possible? Let's talk about the crazy ideas that just might work. Theoretical possibilities. Alright, what if I told you there's a way to travel faster than light without actually breaking any laws of physics? Sounds crazy, right? But that's exactly what some theories suggest. Instead of moving through space, what if we could bend space itself? That's the idea behind the Alcubierre warp drive. Imagine a spaceship that contracts space in front of it and expands space behind it. The ship itself doesn't actually move, it just rides a wave of space-time, kind of like a surfer catching the perfect wave. The best part? Since you're not technically moving through space, you're not breaking the speed limit. But wait, you ask, why aren't we already building one? Well, there's a small problem. The warp drive needs exotic matter with negative energy, something we don't even know exists yet. Oh, and if we did find it, you'd need the energy of a small star to power the thing. No big deal, right? Then there's the wormhole idea. Instead of traveling across vast distances, why not create a shortcut? If space-time is like a folded sheet of paper, a wormhole would be like punching a hole straight through it. Instead of taking millions of years to reach another galaxy, you'd just step through and be there instantly. But surprise, surprise, wormholes also come with their own problems. They might collapse instantly, they might require impossible physics to stay open, and worst of all, they could be unstable portals of doom that rip apart anything that enters them. Fun, right? So, while these ideas sound straight out of sci-fi, scientists are actually exploring them seriously. And who knows, one breakthrough could change everything. But for now, we're stuck playing by the universe's rules. Or are we? Let's talk about the paradoxes of FTL travel, and why it might break reality itself. Challenges and paradoxes. Alright, let's say we somehow cheated physics and found a way to zoom past the speed of light. Cool, right? Well, not so fast. The moment you go faster than light, you break time itself. Yes, you heard that right. FTL travel messes up cause and effect, leading to paradoxes so wild they'd make your brain hurt. Imagine this. You hop into your FTL spaceship and fly to a distant planet faster than light. From your perspective, everything seems normal. But according to an observer back on Earth, you've just arrived at your destination before you even left. How's that possible? That's the causality problem, when effects happen before their causes. Now take it a step further. What if you send a message back to Earth using another FTL signal? Based on relativity, your message could arrive before you even sent it. Think about that. Someone on Earth could get your message and stop you from ever sending it in the first place. Congrats, you've just created a time paradox where reality contradicts itself. Welcome to the Twilight Zone, and it doesn't stop there. Physicists have proposed something called the grandfather paradox. What if FTL travel allowed you to go back in time and, let's say, prevent your grandfather from meeting your grandmother. You wouldn't exist, but then you wouldn't have been able to go back in time in the first place. These paradoxes aren't just annoying thought experiments, they tell us that something fundamental about FTL travel doesn't fit with our understanding of the universe. So, unless we find a way to rewrite the laws of physics, breaking the speed of light might just be the key to breaking reality itself. But wait, there's something even weirder at play. Let's talk quantum mechanics. A glitch in the speed limit. Okay, if faster-than-light travel is impossible, then someone needs to explain what's going on with quantum entanglement. Because in the quantum world, things seem to break the rules all the time. Here's how it works. Imagine you have two particles, one on Earth and one on the other side of the galaxy. If these particles are entangled, changing one will instantly affect the other, no matter how far apart they are. Sounds like instant communication, right? Well, not exactly. Even though this connection happens faster than light, it doesn't actually transmit information. You can't use it to send messages or travel through space, at least not in any way we currently understand. Einstein called this spooky action at a distance, and honestly, even physicists are still scratching their heads over it. But here's the interesting part. Some researchers believe quantum entanglement might be a clue that the speed of light isn't the absolute limit after all. What if our current understanding of space and time is just a piece of a much bigger puzzle? What if the universe has hidden shortcuts that we just haven't discovered yet? Some scientists have even suggested that quantum mechanics could be connected to wormholes, tiny microscopic ones that constantly open and close in space-time. If that's true, could we one day scale them up and turn them into real, usable wormholes for space travel? It's a long shot, but hey, so was flying once upon a time. One thing's for sure, the more we dig into quantum weirdness, the more we realize that reality is way more mysterious than we ever imagined. But what does all this mean for the future of faster-than-light travel? Is it just sci-fi, or could we actually crack the code one day? Let's talk about recent breakthroughs and what's next. Recent developments and research. Alright, so we've talked about how faster-than-light travel is currently impossible, how it could break reality, and how quantum mechanics might be hinting at something bigger. But what if I told you that scientists haven't given up yet? In fact, some mind-blowing research suggests that FTL travel might not be as far-fetched as we thought. Let's start with the Alcubierre warp drive. Remember that sci-fi idea where a spaceship doesn't move but instead bends space around it? Well, in 2021, a group of physicists found a way to tweak the original math, meaning that a warp drive might actually be possible without exotic matter. The catch? We'd still need insane amounts of energy, but hey, progress is progress. Then there's quantum tunneling, an effect where particles seemingly teleport through barriers instead of going around them. Some researchers believe this could hint at a way to manipulate space-time itself. If we ever learn how to scale this effect up to spaceships, we could be looking at a whole new method of breaking the speed barrier. And here's something wild. A 2019 study suggested that faster-than-light motion might actually be possible inside certain plasma waves. Scientists at NASA have even experimented with using plasma fields to manipulate light speed limits inside controlled environments. It's small scale for now, but what if it's a stepping stone to something bigger? Sure, none of this means we'll be zipping through the cosmos tomorrow, but science is all about small discoveries leading to big breakthroughs. If we can keep pushing the boundaries of physics, who knows? Maybe one day we'll look back and laugh at the idea that we ever thought FTL travel was impossible. So, with all this research happening, the real question is, what's next? Let's talk about the future of interstellar travel. The future of faster-than-light travel. So will we ever break the speed of light? Honestly, right now, it looks impossible. The laws of physics, time paradoxes, and energy requirements all stack against us. But here's the thing. History is full of impossibilities that humans eventually overcame. People once believed heavier-than-air flight was impossible. Then the Wright brothers came along. They thought space travel was just science fiction, until we landed on the moon. We believed breaking the sound barrier would destroy an aircraft, until Chuck Yeager proved everyone wrong. The point? Just because something seems impossible today, doesn't mean it always will be. The universe is full of mysteries we haven't unlocked yet, and every day, scientists are getting closer to understanding how space, time, and physics really work. Maybe one day we'll harness quantum mechanics, crack the secret of negative energy, or find a hidden law of physics that lets us leap across galaxies in seconds. Maybe we just haven't asked the right questions yet. But even if FTL travel never becomes a reality, our hunger to explore will never stop. The universe is vast, beautiful, and full of wonders waiting to be discovered. Whether it takes us a lifetime or a millennium, we're going to keep pushing forward, one breakthrough at a time. So what do you think? Will we ever travel faster than light? Or is the universe telling us to slow down and enjoy the ride? Let's talk in the comments. So, will we ever crack the code for faster than light travel? Right now, it's a mystery, but science is always evolving. Who knows? The next big breakthrough could be just around the corner. What do you think? Will humanity ever zip across galaxies at warp speed, or are we forever stuck crawling through space? Let's discuss in the comments. If you enjoyed this deep dive, subscribe to InnoVision Tech for more mind-blowing science and future tech content. See you in the next one. Have you ever wondered just how far we can see into the universe? How far back in time can we peer to uncover the mysteries of the cosmos? The universe is vast, and every new discovery helps us understand it just a little bit more. But here's the big question. What if we could observe galaxies that formed just a few 100 million years after the Big Bang? Imagine what secrets they could reveal. Today, we're diving into the discovery of the most distant galaxy ever found and exploring how far we can actually see. Ready to join the cosmic journey? Let's go! Introduction to Cosmic Exploration. When we gaze up at the night sky, it's hard not to wonder about the vastness of the universe. How far does it really go? And what mysteries lie beyond the stars we see with the naked eye? These are the kinds of questions that drive astronomers and space enthusiasts alike to explore the cosmos. Over the centuries, our understanding of the universe has evolved significantly, thanks to groundbreaking technological advancements and the courage to venture into the unknown. In the early days of space exploration, the ability to view distant galaxies was limited by the tools available to astronomers. Telescopes allowed us to look deeper into space than ever before, but the farther we looked, the more we realized how much we were still missing. That all began to change with the advent of space telescopes like Hubble. Hubble gave us unprecedented views of the universe, showing us galaxies that were millions, even billions of light-years away. Yet even Hubble's extraordinary capabilities were still bound by the limits of the visible light spectrum. But what if we could see beyond visible light? What if we could look at the universe as it existed in its infancy just a few 100 million years after the Big Bang? With the launch of the James Webb Space Telescope, this possibility became a reality. Webb's infrared capabilities allow us to peer further into space and further back in time than any telescope before it. Thanks to Webb, astronomers have discovered a galaxy so distant that it has completely transformed our understanding of the early universe. But what exactly does this discovery mean? How far can we really see, and what can it tell us about the birth of galaxies? Let's dive into this groundbreaking exploration of the most distant galaxy ever discovered. The role of the James Webb Space Telescope. Imagine being able to see something no one else has ever seen before. That's exactly what the James Webb Space Telescope enables scientists to do. Launched on December 25, 2021, JWST has quickly become one of the most powerful and influential tools in the history of astronomy. Unlike the Hubble Space Telescope, which primarily observes invisible light, Webb is equipped to observe infrared light, a type of light that is invisible to the human eye. Infrared observations are crucial for studying distant objects in the universe because, as light travels across the vast expanse of space, it stretches out due to the expansion of the universe. This stretching causes light to shift to longer wavelengths, which we detect as infrared light. Essentially, the farther away a galaxy is, the more its light has been stretched, making it visible only in the infrared spectrum. That's where Webb comes in. Thanks to its cutting-edge instruments, the JWST is able to capture infrared light with an unprecedented level of detail. One of Webb's primary missions was to look deeper into the universe than ever before, and to study the very first galaxies that formed after the Big Bang. This is a critical task because understanding the birth and evolution of galaxies is key to understanding the origins of the universe itself. The JWST's ability to see through cosmic dust and gas allows it to provide a clearer picture of the earliest galaxies, which were previously invisible or difficult to study. By observing these galaxies, astronomers can unlock the secrets of how stars and galaxies came together in the early universe, offering new insights into the conditions that led to the creation of the cosmos as we know it. Webb's findings are already shaking up our understanding of the universe's evolution, and one discovery in particular has captured the attention of scientists and space enthusiasts around the world. But what exactly did they find? Let's take a closer look. Discovery of Jades GSZ 14-0. In May 2024, astronomers using the James Webb Space Telescope made a groundbreaking discovery that would change the way we view the universe. They identified a galaxy named Jades GSZ 14-0, located at a staggering redshift of 14.32. But what does that mean? Well, the redshift of a galaxy tells us how far away it is and how much its light has stretched as it traveled across space. A higher redshift indicates a galaxy that existed closer to the beginning of the universe, meaning Jades GSZ 14-0 is one of the most distant galaxies ever observed. At a distance of around 13.5 billion light-years from Earth, Jades GSZ 14-0 is located in a time just under 300 million years after the Big Bang. This is an incredibly important finding because it provides a glimpse into the earliest stages of the universe, when galaxies were first beginning to form and evolve. To put this into perspective, if we were looking at Earth from this distant galaxy, we would be seeing our planet as it was just a few million years after life began to emerge. The discovery of Jades GSZ 14-0 pushes the limits of what we thought was possible. It challenges the existing models of galaxy formation, suggesting that galaxies were able to form and evolve much faster than previously anticipated. The early universe was a chaotic place full of energy, gas, and radiation, yet somehow in this tumultuous environment, galaxies like Jades GSZ 14-0 were able to emerge. The fact that we can observe such an ancient galaxy is a testament to the power of modern technology, and it raises important questions about how galaxies formed in the first few hundred million years after the Big Bang. What does this mean for our understanding of the universe's infancy, and how much further can we see? These are just some of the exciting questions this discovery raises. Characteristics of Jades GSZ 14-0. When scientists first observed Jades GSZ 14-0, they were amazed by its size, brightness, and activity. Three characteristics that make this galaxy truly remarkable. Despite its extreme distance, Jades GSZ 14-0 appears to be quite luminous, meaning it emits an incredible amount of light for its age. This is particularly significant because galaxies in the early universe were expected to be much smaller and dimmer, especially in comparison to the massive mature galaxies we observe today. So, how is this galaxy so bright? The answer lies in the rapid rate of star formation within the galaxy. Spectroscopic data gathered by the JWST reveals that Jades GSZ 14-0 is actively producing stars, and this star formation process is likely responsible for its high luminosity. The fact that this galaxy is so active in its star formation so soon after the Big Bang challenges current models of how galaxies evolve. It suggests that galaxies in the early universe may have formed and matured much faster than we previously thought. Another fascinating characteristic of Jades GSZ 14-0 is its size. The galaxy spans over 1,600 light-years across, which is a significant size for a galaxy so young. This large size further challenges our understanding of how galaxies grow and evolve in the early stages of the universe. Astronomers expected early galaxies to be smaller and less structured, but Jades GSZ 14-0 bucks that trend. Its size and activity make it a valuable object of study for astronomers who are trying to piece together the story of galaxy formation. Additionally, the galaxy's composition is of great interest to researchers. Observations of Jades GSZ 14-0 have revealed the presence of key elements like hydrogen and oxygen, which are essential ingredients for star formation. These findings provide critical insights into the processes that fueled the creation of the first stars and galaxies. By studying galaxies like Jades GSZ 14-0, astronomers are beginning to build a clearer picture of the early universe and how the first stars and galaxies came to be. It's discoveries like this that push the boundaries of human knowledge and open up new avenues for exploration. What more can we learn from galaxies like Jades GSZ 14-0? The future of cosmic exploration looks incredibly exciting. Implications for cosmology. The discovery of Jades GSZ 14-0 offers more than just a fascinating glimpse into a distant galaxy. It holds profound implications for our understanding of cosmology, the study of the universe's origin, structure, and evolution. As we peer deeper into the cosmos, we're not just uncovering more galaxies, but we're uncovering the very processes that shaped the universe in its infancy. Jades GSZ 14-0, located a mere 300 million years after the Big Bang, provides critical insights into the early universe when stars and galaxies were first forming in the chaotic environment that followed the Big Bang. This discovery is crucial for understanding a period in the universe's history known as the Cosmic Dawn, the time when the first stars lit up the universe, pushing back the darkness of the cosmic dark ages. The light from these early stars helped to ionize hydrogen gas and set the stage for the formation of more complex structures like galaxies, black holes, and even planets. Jades GSZ 14-0, with its high star formation rate and abundant luminous activity, serves as a cosmic time capsule from this pivotal moment in the universe's evolution. Moreover, this galaxy challenges our models of galaxy formation. Until now, scientists believed that galaxies in the early universe would be much smaller and less developed, but Jades GSZ 14-0's surprising size and brightness suggests that galaxies might have formed much faster and more efficiently than we previously thought. This could alter our understanding of how galaxies evolve over time and may prompt astronomers to reconsider theories about the conditions required for galaxy formation in the early universe. As we continue to observe galaxies like Jades GSZ 14-0, we may uncover even more surprises that will reshape the way we think about the birth and growth of galaxies across the cosmos. Future prospects. The discovery of Jades GSZ 14-0 is just the beginning of an exciting new chapter in cosmic exploration. With the James Webb Space Telescope continuing its mission, astronomers are poised to uncover even more distant galaxies, pushing the boundaries of our knowledge further than ever before. While Jades GSZ 14-0 holds the current record as the most distant galaxy ever observed, there's no telling how much farther we can look into the universe's past. The future of astronomy is incredibly bright thanks to the capabilities of Webb and other upcoming space missions. Webb's infrared instruments have allowed scientists to see galaxies from a time long before our solar system even existed. And these observations are not only helping us learn about the universe's origins, but also providing clues about its future. As we gather more data on galaxies like Jades GSZ 14-0, we'll continue to refine our understanding of the universe's history, including the formation of stars, galaxies, and black holes. The implications of these discoveries go far beyond the early universe. They also hold the key to understanding how galaxies evolve over billions of years, which will help us predict the future of our own galaxy, the Milky Way. In the coming years, astronomers expect to discover even more galaxies that existed during the universe's early stages, revealing new secrets about the formation of cosmic structures and the evolution of the universe itself. As technology improves and our tools become even more advanced, the quest to understand the universe's earliest epochs will only accelerate. With each new discovery, we take one step closer to understanding how the universe came to be, how it evolved, and where it's headed in the future. The most distant galaxies are not just objects of fascination. They are keys to unlocking the mysteries of the cosmos, and the journey to uncover them is just beginning. Thanks for tuning in to InnoVision Tech. We've just scratched the surface of the universe's deepest mysteries, but there's so much more to discover. What do you think? How far do you believe we can see into space? Drop your thoughts in the comments below, and don't forget to hit that like button if you enjoyed this journey with us. Subscribe for more fascinating tech and space discoveries, and stay tuned for the next adventure. Until then, keep exploring the infinite possibilities. In 1960, two men descended nearly 36,000 feet into the Mariana Trench, Earth's deepest, darkest frontier. It wasn't just a dive, it was a plunge into the unknown, where light vanishes and pressure crushes steel. Even today, this abyss remains more alien to us than the surface of Mars. Despite decades of exploration, the trench hides secrets we've barely begun to uncover. Life forms defying logic, ecosystems untouched by time. So, if you were there, surrounded by silence and shadow, what would you feel? Let's uncover what really lies beneath the ocean's surface and why it still haunts human imagination. A journey into the abyss. Imagine standing at the edge of the world, staring into an endless blue void where the surface shimmers but the bottom remains hidden in pure darkness. Now picture yourself diving headfirst into that vast unknown, deeper and deeper until the sunlight fades away completely. and you're surrounded by a world so silent, so crushing, so alien, that it feels like you've left Earth entirely. Welcome to the Mariana Trench, the deepest, darkest mystery of the ocean. It's not just a trench, it's a gaping scar on our planet's surface, deeper than Mount Everest is tall. Few humans have dared to visit this hidden world. It's a place where normal rules don't apply, where pressure can crush a human-made submarine like a soda can, and temperatures are barely above freezing. But despite its terrifying reputation, the Mariana Trench also holds secrets. Secrets that could teach us about life in extreme environments, about Earth's past, and maybe even about life beyond our planet. Are you ready to journey into the unknown, where reality bends, and the impossible becomes possible? Because once you cross that invisible threshold, there's no going back. Let's dive deeper, both literally and figuratively, into this uncharted abyss where mystery reigns supreme, and the ocean guards its darkest secrets. The geography and depth of the trench. If you pulled out a world map and looked east of the Philippines, you'd spot a small chain of islands, the Marianas. Hidden beneath these islands is something far more massive and mysterious, the Mariana Trench. Stretching over 1,580 miles long, about the distance from New York to Dallas, and around 45 miles wide, this trench is Earth's ultimate deep dive. But the real crown jewel of this abyss is the Challenger Deep, the deepest known point on Earth's seafloor. How deep is it? Try a mind-boggling 36,070 feet, that's nearly 7 miles down. To put that in perspective, if you dropped Mount Everest into the Mariana Trench, its peak would still be submerged by more than a mile of water. It's almost incomprehensible, right? Yet this trench isn't just a single dip, it's a dynamic landscape with ridges, valleys, and slopes sharper than anything we find on dry land. It's like an underwater Grand Canyon, but far more massive and far more terrifying. And here's something wild, scientists believe there may be even deeper spots nearby that are still unmapped. The trench sits in one of the most geologically active regions on Earth, constantly shifting, evolving, and hiding more mysteries under its crushing darkness. What secrets still lie hidden in those unreachable depths? We're just scratching the surface. Geological formation and features. Let's rewind the clock. Millions of years ago, Earth's surface wasn't the quiet, steady land we know. It was alive, shifting, groaning, and tearing apart like a living creature. That's how the Mariana Trench was born, out of a violent dance between two colossal plates of Earth's crust. Here, the mighty Pacific Plate is slowly but relentlessly diving beneath the smaller Mariana Plate in a process called subduction. Imagine one giant slab of rock sliding underneath another, disappearing into the molten depths of our planet. That sinking action carved out the enormous trench we know today, but it didn't stop there. The collision created an entire chain of underwater volcanoes called the Mariana Arc, a fiery, hidden landscape few have ever seen. Some of these volcanoes are active, constantly spewing minerals and gases into the deep sea. Others are extinct, sitting silently like forgotten monuments in the abyss. Strange features like mud volcanoes and hydrothermal vents, basically underwater geysers, dot the trench, pouring scalding hot water and strange chemicals into the icy ocean. It's a wild, alien world down there, sculpted by forces beyond human imagination. The ground itself creaks and shifts constantly. It's a reminder that beneath the calm blue surface of our oceans, a titanic battle is always raging, shaping our planet, one slow, invisible inch at a time. Extreme conditions. Picture yourself 7 miles underwater. It's pitch black. The cold bites at your skin, and every inch of your body feels like it's being crushed by a monstrous force you can't escape. Welcome to the reality of the Mariana Trench. Down here, the pressure is more than 1,000 times what you feel at sea level. That's like balancing 50 jumbo jets on top of you, at once. No human could survive it without heavy-duty technology. And if you think it's warm down there because of the volcanoes, think again. Temperatures hover just above freezing, a brutal, unforgiving chill that seeps into everything. The combination of crushing pressure and bone-numbing cold creates an environment that is almost completely hostile to life as we know it. Yet somehow, life finds a way. Specialized creatures have evolved biological superpowers, flexible bones, pressure-resistant cells, and metabolism adapted to an energy-starved world. It's almost like another planet right here on Earth. Scientists even believe studying these extreme conditions could unlock secrets about how life might exist on other worlds, like the frozen oceans of Jupiter's moon Europa. But for now, most of us can only wonder and respect the immense power of the deep. It's a world where survival means mastering the impossible, every single moment. Unique and mysterious life forms. You might think the Mariana Trench is a lifeless wasteland, but you'd be wrong. Down there, in the pitch-black cold and mind-crushing pressure, life has adapted in ways so bizarre they almost seem like creatures from a sci-fi movie. Meet the Mariana snailfish, the deepest dwelling fish ever discovered. It's small, ghostly white, and so fragile-looking you'd never guess it can withstand such unimaginable pressure. Then there are the amphipods, shrimp-like creatures that survive by scavenging whatever organic matter drifts down from the surface. Some of them are coated with strange, pressure-resistant exoskeletons that scientists are still trying to fully understand. And don't forget the xenophyophores, gigantic single-celled organisms that look like alien fossils scattered across the seafloor. These lifeforms thrive by embracing the impossible, enduring toxic chemicals, darkness, and crushing forces that would kill most other organisms instantly. What's even crazier? We've barely scratched the surface. Every expedition reveals new, unknown species hiding in the trench's hidden pockets and valleys. It's like a living, breathing mystery box, offering glimpses into how life can survive under the harshest conditions imaginable. Some researchers even believe that studying these creatures might offer clues to how life could exist in the icy depths of alien oceans across the galaxy. The deeper we look, the more we realize life is far more adaptable and more wondrous than we ever imagined. Human exploration and discoveries. For most of human history, the Mariana Trench was just a shadowy rumor, a place we knew existed but dared not explore. That changed in 1960, when Swiss oceanographer Jacques Piccard and U.S. Navy Lieutenant Don Walsh took a daring plunge aboard the bathyscaphe Trieste. In a cramped steel sphere barely big enough for two, they descended nearly 36,000 feet into the Challenger Deep. The pressure outside was so intense that the tiny windows cracked, but they made it, witnessing a seabed covered in thick silt and strange creatures. Fast forward to 2012, when filmmaker James Cameron, yes, the Titanic and Avatar director, made a historic solo dive, reaching the Challenger Deep in his specially designed submersible, the Deep Sea Challenger. Cameron's journey wasn't just for glory. He brought back three-dimensional footage, valuable scientific samples, and new discoveries that rewrote our understanding of the deep sea. Since then, unmanned submersibles and robotic vehicles have continued to probe the trench, discovering ecosystems fueled by chemical reactions rather than sunlight. But here's the wild part. We've explored Mars and the Moon in greater detail than we have explored the Mariana Trench. So while we've made historic strides, the trench remains a realm of mystery. Who knows what still lurks in its deepest shadows, waiting for the next brave soul to uncover its secrets. The future of deep-sea exploration. The Mariana Trench is not just a relic of Earth's past, it's the frontier of tomorrow's discoveries. As technology advances at lightning speed, our ability to explore these crushing depths improves, opening doors to mysteries once thought unreachable. New autonomous underwater vehicles and robotic submarines are being designed to withstand extreme pressure and dive deeper, longer, and with better precision than ever before. Scientists are gearing up for missions that could reveal unknown species, uncover rare minerals, and even shed light on how life can survive in the most hostile conditions. These explorations could have far-reaching implications, not only for oceanography but for medicine, biotechnology, and even the search for life beyond Earth. However, this exciting future also comes with responsibilities. The push to explore must be paired with careful stewardship to avoid damaging these fragile ecosystems. The choices we make now about how we explore and protect the deep ocean will shape what future generations inherit. The Mariana Trench stands at the crossroads of science, technology, and ethics, reminding us that the final frontiers of our planet still hold secrets, and the chance to inspire humanity's imagination and respect for nature in equal measure. Thank you for diving deep with us into the hidden world of the Mariana Trench. It's incredible how much mystery still exists right here on our own planet. What do you think could be lurking in the parts we haven't explored yet? Share your thoughts in the comments. We'd love to hear them. This is InnoVision Tech, bringing you closer to the wonders of science and exploration. And if you love discovering the mysteries of the universe and space, don't forget to like, subscribe, and hit the bell icon for more adventures.
Have you ever wondered how mind-blowing science can be? From the mysteries of the universe to the wonders of biology, science constantly surprises us with astonishing discoveries. Ready to be amazed by facts that defy our understanding and reveal the incredible intricacies of the world around us? Join us as we dive into 10 amazing science facts that will blow your mind. Stay tuned and prepare to have your curiosity sparked. Water can boil and freeze simultaneously. In a phenomenon known as the triple point, water can boil and freeze at the same time under specific conditions. The triple point occurs when temperature and pressure are set just right, allowing water to exist simultaneously in the solid, liquid, and gas phases. This intriguing state can be achieved at a precise temperature of 0.01 degrees Celsius and a pressure of 611.657 pascals. This unique behavior of water is not just a scientific curiosity but has practical applications in fields such as thermodynamics and material science. It also demonstrates the fascinating and sometimes counterintuitive nature of physical laws. Understanding the triple point helps scientists calibrate thermometers and study phase transitions in various substances. Next time you boil water, imagine the incredible conditions under which it could also be freezing, showcasing the extraordinary properties of this ubiquitous substance. The triple point is a reminder of the complex and fascinating behaviors that even everyday materials can exhibit under the right circumstances. Bananas are radioactive. Bananas contain potassium, a vital nutrient for our bodies, but did you know they are also slightly radioactive? This is because they contain potassium-40, a naturally occurring isotope that emits radiation. While the radioactivity in bananas is minimal and harmless, it is a fascinating example of how everyday objects can have surprising scientific properties. The radioactivity of bananas is so well known that it has even been used to create the concept of the banana equivalent dose. This informal measurement helps explain radiation exposure by comparing it to the tiny amount of radiation one would receive from eating a banana. It is a useful tool for putting more significant radiation doses into perspective. Despite their radioactivity, bananas are perfectly safe to eat and remain a nutritious part of our diet. This quirky fact highlights how science can reveal unexpected aspects of the natural world, adding a layer of intrigue to the ordinary fruits we enjoy daily. A day on Venus is longer than a year on Earth. Venus, often called Earth's sister planet due to its similar size and composition, has a day that is longer than its year. Venus takes about 243 Earth days to complete one rotation on its axis, making a single day longer than its orbit around the Sun, which takes approximately 225 Earth days. This unusual rotation pattern makes Venus one of the most intriguing planets in our solar system. The slow rotation of Venus has significant effects on its climate and atmosphere. The planet's thick atmosphere, composed mainly of carbon dioxide, traps heat and creates extreme surface temperatures. This greenhouse effect results in a surface hot enough to melt lead, with temperatures reaching around 467 degrees Celsius, or 872 degrees Fahrenheit. Understanding Venus's rotation and atmospheric conditions helps scientists study planetary dynamics and climate systems. Venus's unique characteristics provide valuable insights into the potential for extreme environments on other planets and the processes that shape planetary evolution. Humans share 60% of their DNA with bananas. It might sound surprising, but humans share about 60% of their DNA with bananas. This genetic similarity highlights the common ancestry and fundamental biological processes shared by all living organisms. DNA, the molecule that carries genetic information, is composed of sequences that can be remarkably conserved across different species. The shared DNA between humans and bananas primarily involves genes responsible for basic cellular functions, such as metabolism, DNA replication, and cell division. These essential processes are critical for life and are conserved across diverse forms of life, from plants to animals. This genetic overlap underscores the interconnectedness of all living beings. Recognizing our genetic connection to other organisms fosters a deeper appreciation for the diversity of life on Earth. It also emphasizes the importance of studying genetics to understand the commonalities and differences that define various species. The genetic ties between humans and bananas are a testament to the shared building blocks of life.
The Eiffel Tower can be 15 centimeters taller during the summer.
The Eiffel Tower, an iconic symbol of Paris, can grow up to 15 centimeters taller during the summer. This phenomenon occurs due to the thermal expansion of iron, the primary material used in the tower's construction. As temperatures rise, the iron heats up and expands, causing the tower to increase in height. Thermal expansion is a physical property of materials that causes them to change shape, area, and volume in response to temperature changes. This effect is particularly noticeable in large structures like the Eiffel Tower, where the cumulative expansion of the metal components results in a measurable height difference. The tower's height returns to normal as temperatures cool and the iron contracts. Understanding thermal expansion is crucial for engineers and architects, as it influences the design and maintenance of buildings, bridges, and other structures. The seasonal height changes of the Eiffel Tower serve as a visible reminder of the impact of temperature on the physical properties of materials.
The universe is expanding faster than the speed of light.
The universe is expanding at an accelerating rate, and this expansion is happening faster than the speed of light. This discovery, made by observing distant galaxies and measuring their redshifts, has profound implications for our understanding of cosmology and the fate of the universe. The accelerated expansion is driven by dark energy, a mysterious force that makes up about 68% of the universe. Dark energy's nature remains one of the biggest mysteries in modern science. It opposes the force of gravity, causing galaxies to move away from each other at increasing speeds. This expansion means that over time, galaxies will become more distant and less visible, leading to an increasingly isolated universe. The discovery of the universe's accelerated expansion has revolutionized our understanding of cosmology. It challenges existing theories and encourages scientists to explore new models of the universe's origin, structure, and ultimate fate. The idea that the universe is expanding faster than the speed of light highlights the dynamic and ever-evolving nature of scientific discovery. There are more stars in the universe than grains of sand on Earth. The number of stars in the universe is mind-boggling, far exceeding the number of grains of sand on all the Earth's beaches and deserts. Astronomers estimate that there are about 100 billion galaxies in the observable universe, each containing hundreds of billions of stars. This staggering number illustrates the vastness of the cosmos and the incredible scale of the universe. The sheer number of stars provides a sense of the immense size and complexity of the universe. Each star represents a potential solar system, with the possibility of planets and even life. The study of stars and galaxies helps scientists understand the formation and evolution of cosmic structures and the potential for habitable worlds beyond our solar system. Contemplating the vast number of stars in the universe fosters a sense of wonder and curiosity about our place in the cosmos. It inspires continued exploration and research as scientists seek to uncover the mysteries of the universe and our connection to it. A single bolt of lightning contains enough energy to toast 100,000 slices of bread. Lightning is a powerful natural phenomenon, and a single bolt can contain up to 1 billion volts of electricity. This immense energy is enough to toast 100,000 slices of bread. The temperature of a lightning bolt can reach up to 30,000 Kelvin, which is about 5 times hotter than the surface of the sun. The energy released by lightning is a result of the rapid movement of electrons between the clouds and the ground. This movement creates a powerful electrical current that generates heat and light. The study of lightning and its effects helps scientists understand electrical phenomena and improve safety measures to protect against lightning strikes. Despite its destructive potential, lightning also plays a vital role in the Earth's ecosystem. It helps fix nitrogen in the atmosphere, making it available for plants to use. This process is essential for the growth of crops and the maintenance of healthy ecosystems. The energy of lightning serves as a reminder of the power and complexity of natural processes. Honey never spoils. Honey is a remarkable substance that never spoils, thanks to its unique chemical composition and natural preservatives. Archaeologists have discovered pots of honey in ancient Egyptian tombs that are over 3,000 years old and still perfectly edible. Honey's low water content and high acidity create an inhospitable environment for bacteria and microorganisms, preventing spoilage. The preservation qualities of honey are due to its hygroscopic nature, which means it can absorb moisture from the air. This property, combined with the presence of natural enzymes and antibacterial compounds, makes honey an excellent preservative. Honey's long shelf life has made it a valuable commodity throughout history, used for both culinary and medicinal purposes. The timelessness of honey underscores the fascinating ways in which natural substances can possess extraordinary properties. It also highlights the importance of understanding the chemistry of food and its preservation. Honey's durability and versatility continue to make it a cherished and enduring part of human culture. Octopuses have 3 hearts and blue blood. Octopuses are among the most intriguing and intelligent creatures in the ocean. and their biology is equally fascinating. These cephalopods have 3 hearts. 2 pump blood to the gills, while the third pumps it to the rest of the body. Their blood is blue due to the presence of hemocyanin, a copper-based molecule that transports oxygen. The unique circulatory system of octopuses is adapted to their underwater environment. Hemocyanin is more efficient than hemoglobin, the iron-based molecule in human blood, at transporting oxygen in cold, low-oxygen conditions. This adaptation allows octopuses to thrive in various oceanic habitats, from shallow reefs to deep-sea environments. Octopus's complex biology and behavior continue to captivate scientists and the public alike. Their ability to change color, solve puzzles, and exhibit sophisticated hunting strategies showcases the remarkable adaptability and intelligence of these marine animals. The study of octopuses offers valuable insights into the diversity and complexity of life in the ocean. As we wrap up our journey through these incredible science facts, it's clear that the world around us is filled with wonders that challenge our understanding and ignite our curiosity. From the extraordinary properties of everyday substances to the mind-bending phenomena of the cosmos, science never ceases to amaze us. If you enjoyed this exploration, be sure to like, share, and subscribe to InnoVision Tech. Don't forget to hit the bell icon to stay updated with our latest videos. Until next time, keep discovering the world's wonders with us.